In this example, we are going to find all local maxima, local minima, and saddle points for the given function. The given function is f of xy equals x to the third minus 3x squared minus 2y squared minus 9x plus 8y plus 7. We are going to use the d-test. Let's make a list what we have to do. First of all, we are going to find the critical point. It could be one or more points. So we're going to use the first partial derivative with respect to x set to be 0. First partial derivative with respect to y set to be 0. And then solve for the solution for x and y to satisfy these two partial derivatives. For the function f of x, the first partial derivative with respect to x is the one that we are going to find the derivative with respect to x. The rest gonna be treated as a constant term. Target the x term. So the fx or the partial derivative with respect to x gonna be 3x squared minus 6x minus 9. And the partial derivative with respect to y for this given function, we're gonna treat y as the variable and the rest gonna be the constant. And we will get negative 4y plus 8, and we let them be 0. And we're going to solve for x and y to satisfy these two equations. The first one, or the one that with respect to x of involving x, and the one with respect to y involving y, that might be convenient for us to take care of one at a time. For the second one, since negative 4y plus 8 equals 0, we can see that y equals 2. And for the x equation, 3x squared minus 6x minus 9. So we're going to factor 3 as a common factor, make it convenient to factor and look for the x value. Now we can factor completely as the product of x minus 3, x plus 1. Then we get x equals 3, x equals negative 1. That means we're going to have two critical points for this function. So the first one, the order pair xy is 3, 2. And the second one going to be negative 1, 2. Next, we're going to compute the quantity d. The d value is from the second partial derivative with respect to x times the second partial derivative with respect to y minus the second partial derivative with respect to x with respect to y quantity squared, and then evaluate at the critical point. Since we have two of them, I'm going to name this as a and b. So a, b. So going to be a1, b1, a2, b2. So since we use the second partial derivative set on the side, the second partial derivative with respect to x gonna be 6x minus 6. Second partial derivative with respect to y is negative 4. And the second partial derivative with respect to x with respect to y, either way, either order, you should get the same value. In this case, if we look at the first one, or the fx, we do not have any y quantity or the y variable in there. That means the second partial derivative with respect to y can be 0. The same as negative 4y plus 8. We find a partial derivative with respect to x, we're going to get 0 the same. Now, from these three quantities, we're going to plug it in to find the d for each case. So we look at one order pair at a time. For the 3, 2, so the d, I'm going to put as a 3 of d2, d of 3, 2 equals the fxx, which is 6x minus 6 multiplied by negative 4 minus fxy, which is 0 square, where x is 2, oh, x3, sorry, x3. So this is going to be 6 times 3, that's 18, minus 6 multiplied by negative 4. That turns out to be 12 multiplied by negative 4, or negative 48. If d is negative 48, which is less than 0, we can say that at 3, 2, it's going to give you the saddle point. And to do further, when we compute the function value at 3, 2, or we put it in the original function, like x to the third, which is 3 to the third, minus 3 times 3 to the second, minus 2 times y to the second, minus 9 times x, which is 3, plus 8 times 2, plus 7 equals negative 12. So then the saddle point, the saddle point is 3 to negative 12 on the graph. The next one, when x is negative 1, y is 2. The d at negative 1, 2 is, we just replace it the same formula, where x is negative 1. So 6 times negative 1 is negative 6, minus 6, and times negative 4, or negative 12 multiplied by negative 4, which turns out to be 48, which is greater than 0. If d is greater than 0, we're going to consider the second partial derivative with respect to x at this point. And in this case, it's 6x minus 6, where x is negative 1. So 6 times negative 1 is negative 6, minus 6 is negative 12. The second derivative with respect to x is less than 0. Since d is greater than 0, and the second order partial derivative with respect to x is less than 0, there will be the local maximum occurred at negative 1, 2. So make a note here. Gonna be the local maximum at negative 1, 2. And then we're gonna compute the value at negative 1, 2 using the function that divided by x to the third, or negative 1 to the third, minus 3x squared, which is negative 1 squared, minus 2 times y, which is 2 squared, minus 9 times x, which is negative 1, plus 8 times y, which is 2, and then plus 7, and the value will come out as 20. So we can wrap it up as is the local maximum point is negative 1 to 20, and 20 is the value. And the saddle point is 3 to negative 12. And we can say there is no local minimum for this problem.